Hi girls, today I'm going to explain the concept from the 5th unit. This is the dynamic memory allocation in C. Dynamic memory allocation means the process of allocating memory at runtime is known as dynamic memory allocation. Although this concept does not inherently have this facility in C, there are 4 library routines which allow these functions which can be used to allocate and free memory during the program execution. For example, if you take the declaration of the array, you have to give the size of the array. For example, A of 10, A of 20, that means we have to allocate the memory. We have to tell the size of the memory. Suppose if you declare the array variable as A of 10, if you give the input only 5 or 3, the remaining spaces are waste in the memory. So to avoid this, the dynamic memory allocation is one of the important concept for allocating the memory at runtime. This is done by using the 4 library functions in C. The 4 library functions are malloc, realloc, calloc and free. So these are all the library functions. If you use these functions in your program, you have to mention this header file stdlib.h like stdio.h. If you use the scanf and printf library functions in your program, you have to include the stdio.h like that. This memory allocation functions malloc, realloc, calloc and free functions are used in your program. You have to include this stdlib.h standard library.h header file in your program. So what is dynamic memory allocation is the process of allocating memory at runtime is known as dynamic memory allocation. C does not inherently have this facility. There are 4 library routines known as memory management functions that can be used for allocating and freeing memory during program execution. The 4 functions are, the first one is malloc and calloc and realloc and the free. These functions are defined either in the header file like alloch.h or stdlib.h or in both. In the memory allocation process, the local variables are stored in the stack. Free memories are called as the heap. The global variables and C program instructions are stored in the permanent storage area. This is the storage of the C program. Local variables are stored in stack. If you write a C program, how the variables are stored in memory are given here. The local variables are stored in stack. Free memories are in the heap. Global variables and C program instructions are stored in the permanent storage area. So these are all the functions of 4 dynamic memory allocation functions. The first one is the malloc, allocating memory, used to allocate block of memory in record size of bytes. This is the syntax given here. Pointer variable is equal to type malloc size in bytes. So this is the syntax. You have to allocate memory as per the rules of the syntax. And then this is the free. This is opposite to allocating memory. It frees the memory. If the memory is already allocated, by using free, you have released the allocated space. So this is releasing the allocated space used to release previously allocated memory space. The syntax is void, free of, void or just free of p. P is the pointer to a memory which has already been allocated by using malloc or calloc. And then the calloc, allocating memory for derived data type, for example arrays and memory so arrays and structures. By using this calloc used to allocate memory space for an array of elements. This is the syntax for this calloc. Pointer variable is equal to type and then calloc is the keyword, here the n and the element size. This is the reallocation, altering the allocated memory, used to modify the size of the previously allocated memory space. This is the syntax. Pointer variable is equal to type star, reallocation, pointer variable, new size. So this is the description for the dynamic memory allocation functions: malloc, calloc, free, and reallocation. Memory allocation allocates a single block of specified memory. The difference between the malloc and calloc is malloc is used to allocate single block of a specified memory, but calloc allocates multiple blocks of specified memory and return of it address. This is used for arrays. The syntax are given there, and then the free is used to deallocate the memory, and then the reallocate memory. If previously allocated memory is not sufficient, you have to reallocate the memory using this realloc function. So this is the syntax of the malloc function. It is used to allocate a contiguous block of memory in the byte. Syntax is given here: pointer name is equal to cast type malloc integer size. This is the example 1. This is the cast type is the integer. malloc, the size of the memory allocation is 10. So the 10 memories are allocated here. Here this is the character star A, and the size of the array is the 20. So this is the calloc. Calloc is used to allocate contiguous allocation. The only difference between the malloc and calloc is that malloc allocates a single block of memory, whereas calloc allocates multiple blocks. This is the main difference. malloc allocates a single block of memory. calloc allocates multiple blocks of memory, each of the same size, and sets all bytes to 0. Now this is the syntax of the calloc. Pointer equal to cast type, calloc keyword n, and the size of the element. Here this is the example. ptr equal to the cast type is the float, allocation keyword 25, and the size of float. This statement allocates contiguous space in the memory for an array of 25 elements, each of size of float is 4 bytes. This is the syntax of allocation. Calloc is used to allocate multiple blocks of contiguous memory in bytes. All blocks are of the same size. I already explained this. Pointer name is equal to cast type, calloc, number of blocks, and integer size. Here this is the example. ptr equal to cast type is integer, calloc is the keyword, and then the 5, 10. Number of blocks is 5, size is the 10. On the execution of this function, 5 memory blocks of size 10 bytes are allocated, and the starting address of the first byte is assigned to the pointer ptr of the type integer. This is the free function. This is opposite to malloc, used to release or deallocate the block of unused or already used memory. The function is free pointer variable. The pointer variable means already the pointer variable is allocated a memory. ptr is equal to int star malloc of 10. This is the memory allocation. This is the pointer variable. 10 memories are allocated. Here by using the free, the memories are released here. Here the example of the free function. This is the int star ptr equal to int star cast type malloc 80 into size of integer. The size of the integer is 2, so 2 into 80 and 160 is allocated here, and it is freed by using the free function. In this example, the memory is allocated using the malloc, then using the free, the function memory is freed. And then this is the altering the size of the block, that is reallocation. Reallocation changes the memory size that is already allocated dynamically to a variable. Now the syntax is ptr is equal to realloc ptr new size. So this is the memory allocation of by using the memory allocation. P1 equal to malloc of 4. The 4 blocks of memories are allocated, and then malloc of 5. The 5 blocks are mentioned in this light blue color, and then the light pink color again malloc of 6 blocks are allocated, so 6 blocks are allocated. This is the free of P2. P2 means the 5 blocks are freed here. So again the P4 malloc fixed allocation failed. So this is the process of dynamic memory allocation. I will explain you the linked list in my next class. Okay. Thank you, girls.